Historically, groundwater in Texas has been governed by the rule of capture, which grants landowners the right to pump the water beneath their property. The rule of capture allows any landowner to pump whatever they can, even if it results in drying up a neighbor's well. Whoever has the biggest pump and the deepest well can keep on drawing down the water level, sometimes leaving neighboring landowners high and dry. However, the landowner must use the water for a beneficial purpose and cannot waste the water. Unlimited pumping of groundwater could eventually affect the longevity of Texas aquifers. Without proper groundwater stewardship, Texas water costs would rise, land could subside in some areas, water quality could degrade, and people in some areas could run out of water.
In response to these potential problems, the Texas legislature authorized groundwater conservation districts to manage pumping. A groundwater conservation district can be formed by citizens to jointly manage their groundwater resources. A district has the local authority to set rules for conserving, protecting, recharging, and preventing waste of groundwater. For instance, it can establish pumping limits and spacing between wells. Landowners and other stakeholders work together on governing their district. Today, groundwater conservation districts are legally recognized as the preferred groundwater management method in Texas. Some districts are composed of one county or even a portion of a county. However, a larger groundwater conservation district may contain all or parts of as many as 14 counties. At the beginning of 2013, there were a total of 99 confirmed districts in Texas.
Stakeholders manage their groundwater resource by first asking themselves the question, what do we want our aquifer to look like in 10, 20, or 50 years? The answer to this question is the desired future condition. A desired future condition is a set of measurable targets that are related to the groundwater budget. Examples of desired future conditions include acceptable average water level declines, maintaining spring flow levels, and preserving aquifer storage volumes. Once the desired future condition is adopted, the district develops management policies such as setting pumping limits to achieve each target. The Texas Water Development Board provides important technical knowledge resources for the districts. The board works with the districts to analyze desired future conditions and calculate the amount of groundwater that may be produced on an average annual basis to achieve those desired conditions. This amount of water is known as modeled available groundwater. In 1998, the board initiated the Groundwater Availability Modeling Program to develop computer models for all major and minor aquifers in Texas. These models are used by the board to estimate modeled available groundwater for the districts and for planning purposes. The models are by no means black boxes that are indecipherable to the public. Each model was developed in a partnership between stakeholders and scientists. The stakeholders supply local information on the aquifer, such as pumping test data and groundwater demands to use as model inputs. The Texas Water Development Board conducts public meetings to communicate model assumptions and explain model results to the stakeholders. Stakeholders may also submit petitions to the board if they question the reasonableness of a desired future condition.
Groundwater planning does not end at the local or county level. The management policies in one district can impact another district, especially if they are using the same aquifer. For instance, a district that raises its pumping limits can draw down not only its own water table, but also that of its neighboring district. To facilitate aquifer level planning, the Texas Water Development Board used the boundaries of major aquifers and political regions to define 16 groundwater management areas throughout Texas. The agency reviews the desired future conditions within each management area to ensure that they do not conflict each other. Meanwhile, every 5 years, each of the state's 16 planning groups adopts a regional water plan. Then the following year, the state of Texas incorporates these plans into a state water plan to serve as a guide to state water policy. The State Water Plan compiles and projects the water needs of all water user groups: homes, cities, farmers, factories, ranchers, miners, and power companies. The plan is submitted to the Governor and the Legislature of Texas and includes recommendations on water projects to meet water demands 50 years into the future. Within the plan, all sources of water, surface, groundwater, and new technologies such as desalination are considered, as well as the effects of water conservation.
Estimates of modeled available groundwater form the basis for how much groundwater is available to use now and throughout the planning horizon. Through the Groundwater Availability Modeling Program, local, regional, and state groups are using local knowledge, scientific know-how, and policy expertise to provide clear, in-depth, and science-based guidance for management of Texas groundwater resources.